Okay, here, this is a follow-up to my lecture on counting and the hypergeometric distribution. This is going to be more hands-on and calculational and less theoretic than the previous one. Start off with an example. A club has 7 people. It needs a president, a vice president, and a treasurer. How many ways can this be done? Okay, well, to begin with, it's a permutation problem because we are assigning offices, and that's labeling. And when you do labeling, that's induces an order. It's permutation. So there were 7 people from whom we were choosing 3 labels, and so we apply the formula 7 factorial divided by 7 minus 3 factorial. And remember, 7 minus 3 is 4, right? You do that subtraction before you take the factorial. So 7 factorial over 4 factorial, this is 5040 divided by 24. That brings us to 210. Okay. Example 2, a 4th grade teacher teaches a class with 20 kids. There are 8 days for which the teacher needs a parent to bring treats. How many ways can the teacher fill his calendar? Okay. Well, again, it's permutation because assigning the dates to the parents is labeling. So you have 20 parents, 8 days to fill. Okay, so 20 factorial over 20 minus 8. Okay, 20 factorial over 12 factorial. And here it gets kind of freaky. You put this in your calculator, and your calculator is going to give you something that you might not have seen before. Here I put down the answer 2.43 times 10 to the 18th. Not all calculators will put that 10 to the 18th there. They'll sometimes just put the 18 up in the corner, and that's understood to be 10 to the 18th. And the thing that this is something that has like 18 places that follow the 2 here. So this is a huge number. Here in the denominator, okay, 4.79 times 10 to the 8th. 10 to the 8th is 100 million. And so this is like about a half a billion here. You do the arithmetic on this, okay, it works out to 5.07 times 10 to the 9th power. So this is about 5 billion. So there are 5 billion ways that you can assign parents to the different days. Seriously, that's big. Okay, example 3. The Ima Sacha Gufa fraternity has 9 members. 4 are needed to go get beer. How many ways can this be done? Okay. Well, it's a combination problem. Why? Because there's no differentiation in the group. Okay. It's a combination, just 4 guys getting beer. There are 9 in the fraternity. 4 of them say, hey, we're going to go get beer. And so you have your 9 factorial over 4 times 9 minus 4. So the 9 factorial over 4 factorial times 5 factorial. And so this is 300, the 9 factorial is 362,880. 4 factorial is 24. 5 factorial is 120. You do the math on this, and there are 124 ways to go get beer. Okay. Example 4. A mother dog has 6 puppies. The owners are going to keep 2. How many ways can this be done? Okay. And again, this is a combination problem. Here I'm using the symbol 6 choose 2. I could have just as well done 6C2, right? Because they mean exactly the same thing. It's just historically this symbol arose separately than the other notation did. In any case, 6 choose 2. This is 6 factorial over 2 factorial times 6 minus 2 quantity factorial. So 6 factorial over 2 factorial times 4 factorial. You go 6 factorial is 6 times 5 times 4 factorial, right? Because this would just go 4 times 3 times 2. But see what happens. We can cancel that out with this. 2 factorial is 2, so it's 30 divided by 2 is 15. I just did a little arithmetic there to show you some shortcuts in case you ever have to do this by hand. Okay, example 5. In a class of 46 students, 21 are female, 25 are male. What is the probability that a sample of 6, exactly 3, would be female? Well, this is a hypergeometric problem, and which, recall, have success and failures. What determines success? Well, success is determined in what probability you're asking for. If you're asking what are the probability of female, then female is your success. Okay, so in this, A is equal to 21, B is equal to 25, N is equal to 6, X is equal to 3. We have our formula to feed here. Okay, and so we feed it. You know, put 21 in for A, 25 in for B. We have 6 in for N. Okay, then we have X is 3, and this right here, this 3 is 6 minus 3, right? And so the 46 is the 21 plus the 25. Okay. All right, you take that and you do the math on it. 21 choose 3 is 1,330. 25 choose 3 is 2,300. 46 choose 6 is 9,366,819. Again, do the math. This works out to 0.327. Example 6. The class described in the preceding example had 26 males. Of those, 11 anticipate a degree in engineering technology. What is the probability that in a sample of 5 males, exactly 2 of these will be anticipating a degree in engineering technology? Okay, so engineering technology is a success in this because we asked, that's the probability. Okay, so probability is the success is 11. Okay, the remainder of the 26, the 15, those are considered failures in this. Taking a sample of 5, what is the probability of 2 successes? Okay, and feed the formula. Okay, all right, go there. 5. Okay. 2, and I should have made that this right here, it should be a 2, right? And right here, this is 5 minus 2 is 3. Okay. So again, we have it there. We fed the formula. Then you 11 choose 2 is 55. 15 choose 3 is 455. 26 choose 5 is 65,780, and this gives us 0.380. And a good way to study this is to go back over your PowerPoint slides and try to replicate the math on them. Go through them by hand. Even if you see them there, it never hurts to go back over them and find the calculator keys again. The class of the two previous examples has 21 females. Exactly one of these anticipates a degree in engineering technology. What is the probability in a sample of 10 females? None of them would be seeking a degree in engineering technology. Okay. So success in this is, again, a degree in engineering technology. And so of our sample, exactly one success in the population. Okay. And 20 failures. We're taking a sample of size 10 and exactly none, and so that is x equals 0. So this x equals 0 right here. Should have that 0. This is the 0 there. This is the success. This is the failure. This is, okay, my sample size. This is the 10 minus 0 right here. And this right here, 21 plus 20 is 21. Okay, and you do the math. Okay, 1 choose 0 is 1. 20 choose 10 is 184,756. 21 choose 10 is 352,716, and it works out to 0.523.